Welcome back to this continuation of our study on the ANOVA for the metabolites and the Alzheimer's disease. At the end of the previous video, didn't quite have time to touch things up in order to complete this and then show you the results. So let's come in here. What we need to do is go into this p-value table, and again under home, replace the bracket 1 with nothing. And then we need to select this column only, because any word that has NA in it will get replaced with nothing also, a mistake I was making before. So if we select just this column that includes the numbers with the NAs, and we now put in the NA here, it'll clear up just all of those. Okay. So this way we didn't change any of our names. If there was an NA in any of the words, then it would replace those with nothing and change the name of our metabolites. But anyway, what we want to do next in the same column is replace N with some number that would be not significant, right? Not less than 0.05. And so there were 20 of those. And then this we save as the number 2. So we're replacing the one that we had there because I did it before, made a mistake. And this is telling us, are you sure you want to dump to a CSV? You lose from formatting. Well, we don't want the Excel formatting, and I don't want to save it. I just want to close it, because if it is not closed, R can't work with it. Okay, so we're back here. We did this step. We got rid of those. And now we can run this one and choose our PV table 2. And now when we make the table 4, we shouldn't get that error message that we got last time. Okay, that went well. And so when we write the table to this file, now we can come in with Excel and File, open the One Way ANOVA P less than 0.05. And we can just click finish here because it is properly delimited. We just need to shift our column titles over. Expand this so we can see the names of our. So now we see here that all these p-values are less than 0.05. So now what we need to do is, this is the original. Right. These numbers, I think, are the original values from the database anyway, because they're all numbered in the database, if you recall. What we can do here is we can go to Data, Sort, and we can sort on the p-value. So I clicked there on Data Sort, and then from the selection, remember you have to select everything in a spreadsheet because the rows and columns are not locked. And so here we can see that we sorted from the smallest to the largest. And so there are 26 metabolites that are statistically significantly different. There's a, for which the ANOVA was statistically significantly different. So there's a significant effect of the age versus stage of Alzheimer's disease is the way that we would interpret that. And I didn't get the R code set up so that it would dump out the Tukey's results with that, but as you recall, we had the ANOVA Tukey's results here. So we can go into Word, and I saw that alpha ketoglutarate was one of them there. So we can search for that. We can find alpha ketoglutarate. Maybe there was a space in between them. Glutarate. Let me just do ketoglutarate. Ketoglutarate. Okay, there we go. So what we can do, ideally we'd have all this kick out, so we'd have the Tukeys right underneath each one of these. It's just a matter of getting the code correct. It's not that it's wrong, it's just that I didn't have time to get it all set up to do that. But here you can see for that one, we have our ANOVA table. Probability less than 0.05. 3 of these, so it's very significant. Here's our code down here. P less than 0.001. Much less than that, obviously. And then the Tukeys results are here. And we see that we have a significant difference between the incipient and the control, the moderate and the control, a severe and a control, and the moderate and the incipient, but there's no significant difference between severe and the incipient or moderate stages of Alzheimer's disease. So it's still a bit bulky, but it lets you do a little bit with R code and see that once you have your R code working properly and everything falls into the same template, you can analyze a lot of data very quickly. It takes some effort to get the code put together, but once you've got it put together, it goes quite rapidly. So what we would say here is that the One Way ANOVA for alpha-ketoglutarate was statistically significant. And then we'd put into brackets. Let me just type in here how we'd do that. The ANOVA was significant. We'd put into brackets F, and then open parentheses. We would put the treatment degrees of freedom with a comma, then the residuals. So we put 3,26, close, equals, we put our F value, 13.01, and then a semicolon, P less than, if we want to put the actual one in here, just grab this, Control C, Control V, and notice that is these would be adjusted. So that's how we report the results of the ANOVA, right? And then we would just go through and state that, see these two here, we'll go back to the full view. So here's the results of the ANOVA. The One Way ANOVA was significant. We report the F value, the degrees of freedom. Remember, there are 4 treatment groups, so they're here, and then this is based upon the total number of samples evaluated. Here's our p-value for the ANOVA, and then we report our p-values separately. So moderate versus control and severe versus control were significant at p less than 0.0001, right? And 001 if you wanted to do it that way. And then, I was wrong, incipient and control is not less than 0.05. So only 3 of them are significantly different. And then the moderate is different from incipient at p less than 0.05. So that's how you would report those. You can see where there is significance, the 0 would not fall between the lower and the upper 95th percent confidence intervals. And then these are the differences between our groups. Just this column right here, the differences between the means. Okay, so I hope that helps you to understand one-way analysis of variance a little bit better, and the use of R. Now what we can do is we can open the other R, so I can just close this, and now I can open that other script. Okay. So I think we can just go with the AD that we have in there. And what this one is going to do is it's going to go just to column. So it's just another way of doing the summary of the ANOVA, but it's going to run it on a select column. Now we're getting our TukeyHSD, and in this case we're just going to capture our output into two separate files. So whatever is in column 55 is going to get analyzed in this one. Let's see if it'll run. So it's running. It's looking for column 55. It'll run that, and it'll dump out two files. The One Way ANOVA summary columns, and then the TukeyHSD column. It's a lot of columns to search, so it's taking a bit of time to find it. And it's slower because I'm recording as well, so it's done. Now we can come in, and what were the name of our files there? One Way ANOVA summary columns. Okay, so this is the column number 25. I didn't have it set up to dump out the column name. That's why we had to include the column name before. We don't know what it was, but anyway, it's not significant. And the other file was the TukeyHSD results column. Anyway, just for a chance for you to see a little bit different code, and none of these are significantly different from each other either. So whatever it was in column 55, you'd have to go and find that. But anyway, it's just another code to run for you to see that it is possible to work with R. You know, the code is not so tricky. You can learn a lot from books that are available and from the internet. It is not an impossible software to work with. And I hope you were able to learn a little bit from this, and I appreciate